Well, hello Beppy. I have had a rush of blood to the head, and this weekend I decided to get the clock back going again. So we've got it on test at the moment. And this is a view of the clock with the door closed. So we've got at the moment the PC board simply hanging by its wires in the case, but we'll get to fix that. This face is an old gent's face with a gent's impulse mechanism, and it's not connected at the moment. There is a transistor on the board to drive it, but that's the least of our concerns right now. And you can see various LEDs on the monitoring the pendulum. So the one on the right hand side is the hip LED. That's the one that I use to determine when to generate an impulse. And these two on this side are the one on the left hand side is bottom dead centre, and the one on the centre lead or the one on the slightly right of that is simply an indication that we're in mid-swing. To actually decide which way the pendulum is moving and whether we're passing bottom dead centre on a leftward swing or a right hand swing is actually a little bit tricky, as you probably know. So I've written drawn a state diagram, and we've got 8 or 9 states. State 0 being when we're sitting on the hip lead on the far right hand side, right through to state 8 when it's finished an impulse and back heading towards the right. And we appear to got it right because the impulse is always happening on a left hand swing, which is obviously what it should do. LEDs that you can see flashing, the one on the right hand side on your right, not quite sure whether you can see it at the end of the video, is the one that I use for the hip detect. So when that LED stops flashing, then I do an impulse, a hip impulse. The two LEDs on the left hand side, the first one is what I call the mid LED, and it's just simply an indicator that we're in mid swing, and the one on the left hand side is at bottom dead centre. So that one is just lit when the pendulum is hanging freely. The impulse you can see on the coil, which happens about every 10 swings or so. I haven't actually counted them. At the moment I've got an impulse of 150 milliseconds. Which is a little bit more than ideal, but I'm just playing with it at the moment. The coil is running on 12 volts DC. I thought it was 5, but it's not, it's 12. It's a 24 volt coil, and at 24 volts it pulls 1 amp, so I haven't measured the current at the moment, but it's probably a few hundred milliamps, probably close to 500 milliamps, and the impulse happens, just starts at bottom dead centre. I don't have the microset connected to it at the moment, but I have got a counter on one of the LEDs, and at the moment our period is 1.9997 seconds, so it's a little bit fast. The trace at the top is one of the LEDs, so I think it's the bottom dead centre LED, and the impulse happens at the left hand rising edge. There. Again, I haven't optimised the position of the impulse, and I haven't experimented with the impulse. Obviously in the processor I can delay the impulse or advance the impulse in software. At the moment I've got a monitor on the processor. I don't know, you probably can't read what's on the screen, but I've got an artificial clock on the screen just simply to help me adjust the pendulum position. It's part of the software, and that's about it really. The case, I led you astray yesterday, the case is a little bit bigger than a synchronome, not much, but it's slightly larger. At the moment it's a bit of a mishmash of wiring. I've got the oscilloscope connected to it, the oscilloscope and the counter connected to it, but I have been running it overnight with the door closed, and I haven't done any time-keeping trials on it yet because I only got it going yesterday, and as you well know, it takes quite a while to get things operating accurately. If I change, at the moment, as I say, the impulse is 150 milliseconds, so I can change that in software. I'll do that now. So if I bring the impulse back to 100 milliseconds, right, so we have the impulse now set at 100 milliseconds, and it will impulse more frequently, about every 5 swings. One, two, three, 4. 1, 2, 3, 4, 5, 6. Yes, about every 4 to 5 swings with a 100 millisecond impulse, which is probably more accurate. If I bring the impulse back to say 75 milliseconds, trying to do this with one hand, so we'll compile the code and upload it. Right, so we're now impulsing a 75 millisecond impulse. One, two, three. 1, 2, 3, 4, 5. So at the moment it's running as an electronic hip, obviously, and with the door open, of course, the losses are higher than they would be with the door closed. I haven't actually counted the number of swings between impulses with the door closed. I'll do that shortly. Okay, I've set the impulse back to 75 milliseconds, and the impulsing happens more frequently. about every 3 or 4 swings. 1, 2, 3, 4. 1, 2, 3, 4. So that's probably conducive to more accurate timekeeping, of course, because the variation between swings will be less with the more frequent impulsing. It's in the middle of summer in New Zealand at the moment, and it's about 24 degrees in my office, and so I've got the window open and there's a bit of a breeze coming in through the window, which is obviously disturbing the pendulum, and the timekeeping is all over the show. I've got the counter gate set to its maximum. Not sure what that is, 20 or 30 seconds. So that that period of 1.999764 seconds is the average over the gate time. And the little flash that you can see on the trigger is synchronized with one of the LEDs on the pendulum. When I get a bit more organised, I'll connect a microset to it. I do have a microset, and I'll connect a microset to one of those opto isolators that I'm using to detect the pendulum position, and I'll do that with the door closed, obviously. So that's what we're up to. Tell me about your experiments.